Okay, so we will start with chapter 3, okay, because I think between chapter 2 and chapter 3, I think most of the students you need extra revision for chapter 3, sir. Yeah. So we start with the page 22. Yeah, chapter 2 is quite simple. Chapter 3 is the one that normally students a bit weak. Okay, so we go to chapter 3. Okay, we started with the chapter 3 uh for the empirical formula first. Okay, so later if we have time, then we go back to chapter 2 lah. Okay, so okay, what is the meaning of molecular formula? So you read that first. It's a chemical formula show you the actual number of atom of each element in a compound. Can you read this one first? They'll ask you either what is a definition of empirical formula or molecular formula. So this one is the one that coming out lah. This experiment is very high chance coming out in your June exam. Either this one or the other one, the copper 2 oxide experiment. We will start with this one first. Then later after that, we will do the calculation and then the writing formulas, all this. Yeah, so right now. Okay, so remember, they will give you this, the mass. Then from there, okay, after that, this is magnesium. Then this is oxide. Okay, in order to get the mass of the magnesium, right? This is number 1, this is number 2, number 3. So you take number 2 minus number 1. This one take number 3 minus number 2. Okay, so you minus off. You remember this one is quite simple, this question. I need to show the calculation because the teacher will mark quite strict. After that, the number of moles, remember, is mass or molar mass. So the mass of magnesium is 24, 16. So 1 is divided by 24, 1 divided by 16. Okay. Then the ratio, right, you need to show divide by the smaller number. Lah. So 0.05 divided by 0.05. You don't have notes yet. Maybe you can, because later got video playback, so you either can take the video, or another one is you can write in the test pad first, then ask me any question that you want. Because live class you can ask, so you will get ratio 1:1. Okay, the magnesium. The purpose of this experiment is to know the ratio of the magnesium and oxygen. It should be ready, but the same website you enter the room, there's another click for you go for the video. Which branch? Okay, so once you get this already, you can write the chemical equation. So this is the one you need to practice there. So magnesium is Mg plus oxygen O2. You have to check with the counter auntie. Should be arrived there. Okay. After that, ratio 2, 2. Oh, you are the one that I think the post or you branch collection. Then you can go to collect that. Because you see, if you any question, you just ask me. If you take number 2 minus number 1, right, you see, number 1 is crucible plus lead. Then number 2 is crucible plus lead plus magnesium. So you minus, right, you cancel these two, then you get magnesium. So this is how you get magnesium. Then how do you get your oxygen, right? You take the third one minus the second one. So you cancel this, you get oxygen. Any question, just ask me. Because this is the question you're going for the exam. Okay, for this experiment, right? The purpose of this experiment is to when you burn this thing, okay, when you burn this thing, right, it will come out white color magnesium oxide. Okay, because this one, when you burn with oxygen, it become magnesium oxide. So magnesium oxide, right, is a white film. This white film, right, it might fly out, means it will escape out because powder plus hot air, the white powder will fly out. So when it escape, right, it will affect this mass. Example, this one supposed to be 40.5 ma. Let's say if it fly out 0.5 grams, then your mass won't be accurate. So in order to make sure it don't like escape, this is what you do. You take your crucible lid, you cover it. Don't let him come out. Cover it. So the standard, they will ask you why you need to close it when it start to burn. Okay, when you start to burn. But if you fully close it, it might unable to have enough oxygen to burn with the magnesium. So this is what we do. You need to open this thing a while. The aim is to get this formula, magnesium oxide, to know the empirical formula of the magnesium oxide. Okay. Then we have to, if you close it, not enough oxygen, you need to open a bit to let oxygen to enter, then close it back. Okay, so this is another method they ask you. So you open a bit to allow oxygen to enter, then quickly cover back again. So you yeah, because you need to make sure all the reaction has been completed. This is normally your June exam, right? You have one question. This is the question. You have two possible questions. One is this one, and the other one of them will come out. So I need to practice this first before we go for the third part. When we do chapter 3 first, then if we later we have time, we do chapter 2, because chapter 2 is very theory, and the question quite standard one, so you can do the chapter 2 later. Then the chapter 3 is the main one. that students will have problem on during the exam lah. Just to do quite direct. Proton number, neutron number, that later you can maybe end of the class, we can do a bit. Now while you're still starting, then we focus on this one. Okay, the purpose of the experiment is to change magnesium into magnesium oxide. Okay, so the mass will slowly increase. Yeah, later we go through the quantitative, qualitative. The same link, the website, right? You just now you enter through the website, right? Then there got the video, there got the answer, there got the PDF file. Yeah, everything is there. Same website, got a few click on. A click to enter the classroom, a click for the video, a click for the PDF file, and the answer. Yeah. So explain how do you ensure reaction is complete. So now we started with, let's say this is 5 gram, then this is 9 gram. Okay. So how do you make sure the reaction is complete? Is that is when you heat, right, you will from 5 gram change to 9 gram. So if not complete, it might be 6 gram, it might be 7 gram, it might be 8 gram. But when it reaches the 9 gram, the increase will stop here. Means the reaction is complete. So this is the question they always ask in the exam. That heating, cooling, weighing process is repeated until you get a constant mass. Means the mass become constant here. So this is the one that the theory questions are. Calculation is not that tough. Then the theory question they will ask is why need to close it? How do you ensure the reaction stops? And then what is the precautionary steps that let's say not enough oxygen? How do you open? Should you just open like this, or you should open then fast close back at least? These are all the standard question. This one is we complete this like first 15 minutes. We done this question, right? You have one question that about 9 marks to 10 marks. Yeah, it's the fastest to give you a 10 marks first. Yeah. Then okay, why this method is not suitable for the copper? Okay, based on the reactivity series, we know that copper is below the less reactive. Okay, so copper is here, then magnesium is here. So the copper is less reactive metal. This is more reactive metal. So this method is not suitable because copper is the reaction very slow. The reaction is very slow. This one is another question they'll ask. So I will give you all the popular question for the exam. Yeah, done this. Okay, this is the first experiment. So this is the first experiment. You all done already? Okay, once you're done already, we'll go for the second experiment. Okay, for the second experiment now, is purposely for copper. Okay, for the copper, because copper is less reactive, so you won't, if you burn it with oxygen, the reaction is very slow. Means I take Cu, I burn with oxygen. Yes, it can become copper 2 oxide, but it's very slow. So for the copper 2 oxide, right, this is we need to use for this experiment. Okay, this is the experiment we're going to use. Since we know that Cu plus O2 becomes CuO is very slow. This is page 20. If you add the definition for the empirical formula, simplest ratio. So this is very slow. Okay, so for this experiment, the lab assistant, they'll burn for you. Okay, the lab assistant will burn for you. They'll get burn the oxygen with the copper to get copper 2 oxide. Okay, they help you to burn it. So after that, you get copper 2 oxide. Then after that, you use hydrogen. Because hydrogen is more reactive. Okay, you were able to take away the oxygen from the copper. So you get the same result, starting with copper 2 oxide become copper. Yeah, how do you dry hydrogen gas? Pass to this anhydrous calcium chloride. So how this thing works is, this is hydrochloric acid, this is zinc. So when you add these two together, they will produce hydrogen gas. So you can write down this Zn plus the zinc plus the hydrochloric acid. It will give you zinc chloride plus H2 and balance equation. So this will give you hydrogen gas. It'll give you hydrogen gas. Okay. So after you produce the hydrogen gas, so this hydrogen gas, this is H2 here, they will flow to this copper 2 oxide. So after that, the hydrogen will take away oxygen from the copper 2 oxide, then become copper. So you change CuO to Cu. Yeah, so the experiment, then CuO is a black color solid, and then Cu is a brown color. Copper is brown color. So this one will be the black solid will turn into brown. You can write in detail, but the purpose is to produce hydrogen gas. Yeah. So the mass here, same concept. Then here got the copper, and here got the copper oxide. So this one, during the exam, you had to refer to individual diagram. So for this one, same. To get the copper, you take number 2 minus number 1. Then this one take number 3 minus number 2. So you minus off. Okay. Yeah, for that, you take the 12.8 divided by 64. Then 16 divided by 16. Okay, the purpose of these two experiments is to get the empirical formula. One is for the more more reactive metal, one is for less reactive metal. Yeah, I roughly go through this experiment. If the mass they give you 2 decimal, use by 2 decimal. It's 3.2. So once you divide it, you'll get the ratio is similar. You get the ratio is similar. Then you need to write this step of 0.2 divided by 0.2 equals to 1. So you get the ratio is 1 to 1. Once you get the ratio is 1 to 1, this is the equation as I write out for you just now. We can confirm the ratio is 1 to 1. So CuO burn with hydrogen gas. Then the hydrogen gas will take away oxygen from the copper. Okay, so for the empirical for magnesium oxide, they always ask you why you need to close it, and because to avoid the white film to escape, then why you need to open a bit is to allow oxygen to enter. So for this one, they will ask about because hydrogen gas is a dangerous gas. Okay, so you need to make sure it's safe in order to conduct the experiment. So imagine let's say I want to heat this chemical, this copper 2 oxide. If inside got hydrogen and oxygen gas together, if you heat, you explode. Okay, so how do you make sure no more oxygen in the tube, right? This is what we do. We will continue flow the hydrogen gas in NZ. Because if you continue flow hydrogen gas, you're actually forcing the oxygen to go up. Yeah. So you need to continue flow before you start heating to make sure there's no air. Air means oxygen. Okay, because heating the mixture of oxygen and hydrogen gas if the second sentence is if you have 2 marks, then you write lah. Yeah. This is the experiment part. You let the hydrogen gas to enter until you force all the air to come out. Okay. Then same after you complete the experiment, you need to continue flow the hydrogen gas, because if you stop flowing, the oxygen might enter back. So once it enter back, right, you react with the hot copper, it will form back your copper 2 oxide. So you need to wait until your hot copper to become cold. Cold means back to room temperature. Need to become room temperature first. These are all the popular question in the exam. Okay, so you need to enter, need to continue flow hydrogen until it become cold. Only you stop the hydrogen gas, then your oxygen will flow back. So when it's cold, it won't react with the copper again. So you have to make sure that air don't enter, because oxygen will react with hot copper to form back the copper 2 oxide. That's why you need to wait the copper to become cold. So this is all the question that come out, standard question will come out for these 2 experiments. So your first term, you need this one to help you to get good marks. So this method not suitable for the magnesium oxide, because if you use magnesium oxide, you burn with hydrogen, right? They won't have reaction, because magnesium more reactive. So this method, so these are the 2 experiments that coming up in your exam. Yeah, I think some school midterm you will have the June exam or July exam, they will have the essay. So essay, they might ask you to compare these 2. We try one essay question later after this question. So first I need to settle this one. Then second one, we go for the calculation. Yeah, so you're done with it. So once you're done with it, we move on to the, okay, you might get a question look something like this. Your turn to page 24. Page 24. Okay, so this is the question for the essay. Okay, they ask to compare these 2 experiments. Okay, so we start with the comparison. Oxygen can remove out of the cluster. So until no oxygen, you force all the air, just like you keep blowing new air, so the old air will go out at least. So for these 2 experiments, let's say they come on and say, they ask you what is the difference between these 2. They ask you to compare. Okay, so for the first one is Mg burn with oxygen, it becomes magnesium oxide, balance equation. For this side is copper 2 oxide burned with hydrogen, it becomes copper plus H2O. Okay, so you write the similarity first. So what is the same is both got heating. Okay, both got heating, and then both is using a gas. This is oxygen gas, this is hydrogen gas, and a solid. They want you to find out the similarity and differences. And you might get this essay in your exam. So after that, one side is metal oxide is formed. One side is metal is formed. The differences. And one is red with oxygen gas. The differences are one is red with hydrogen gas. This one no calculation involved. It might give you 6 marks here, then it give you a small calculation below. Yeah, then after that, one, the mass is increased. The reason is this is the Mg change to MgO. The mass increases. One is the CuO becomes Cu. The mass decrease because it lost oxygen. One side gain oxygen, one side lost oxygen. That's why one mass increase, one mass decrease. Okay, so we've done the first theory, chapter 3. You will have one theory question for these two experiments. Quite standard one, all school the same. Either the first experiment come out or the second experiment. So now you get one question in your paper 2 with yeah. So you go for the second question, which is the calculation. School will have at least one calculation question. I can write in table as long as compare. Okay, because we only have 2 hours. Of course, the seminar we don't arrange very long because we're worried that you cannot focus. Last time we used to have a 3-hour seminar, but because 3-hour seminar is quite packed, a lot of students very tired on the second class. Today is different. Today is like because today is school holiday, right? So we can have an extra class here. Okay, so this is the first question. So using about 35 minutes, we done one question. Confirm either is the first experiment or second experiment. Okay, so then the essay will be something similar to this. That they have calculation will be similar to the structure. The only difference they will ask you to compare these two methods. Okay, so another one you can write one. Another differences you can write. This is for more reactive metal. This is for less reactive metal. So done already. Okay, so now we'll go through the calculation. The rest you can try. The answer will be posted in the website for you. Okay, so this is the second. Okay, so we done the first. Okay, normally for school exams, for midterm, you will have 2 questions from chapter 2, then 2 questions from chapter 3. Normally, 2 to 3 questions. So one of the question will look at this. They'll give this Panadol. So now the first step is you have to calculate how many carbon you have. Means I want to get the actual formula. So carbon I have 1, 2, 3, 4, 5, 6, 7, 8. So this will be C8. Then hydrogen, calculate how much? 3, 4, 5, 6, 7, 8, 9. So H9. Then the third one is oxygen, 1, 2. So the formula is O2. Okay, so remember they'll give you a structural. Then from the structure, you calculate how many C, how many H, and how many O you have. Okay, for nitrogen. Yeah, so add in the nitrogen also. Okay, then you calculate the molecular mass. So we have 8 carbon. Carbon is 12 plus 9 hydrogen plus 1 nitrogen and plus 2 oxygen. Yeah, got N here. Yeah. So here they'll test you about, you need to know what is the difference between relative molecular mass and molar mass. So normally, let's say your school exams are chapter 1, they will have maybe one question. Then chapter 2 will have two questions, something like this. Then chapter 3, they might have two questions like this. Example similar can be roughly at least lah. So chapter 3, one of the question will be the experiment, just now we did it. One more will be the calculation. You might have two calculation questions, something like this. Okay, so after you calculate this, okay, what is the difference between the molar mass and the relative molecular mass? They actually same unit, same number. The only difference is one is 151, one is 151 gram per mole. So in exam, you have to refer to the school exam questions. If they want relative molecular mass, it's 151. If they want molar mass, you have to write gram per mole. Means relative molecular mass, you cannot write the unit. There's no unit. Okay, then now they want you to calculate. Okay, we know that the Panadol that we take, right, is about 500 milligram. So now they want you to calculate how much molecule you have in 500 milligram of the Panadol. So now the first step, milligram to gram, you have to divide by 1000. Divide by 1000. Okay, so for this, we'll go through the formula. We have three formula that we learned in exam. So number of mole is equals to mass over molar mass. Volume over molar volume. There are only three formulas here. Then number of particle over Avogadro constants. Okay, so for the first formula is for gram. Then second formula is for the volume of gas, like DMQ, CMQ. Then the third one is when they ask you to find atom, molecule, or ion. So you can see now you have gram. So you are changing mass into molecule. So first, you write the steps for both. Okay, so we're changing mass for this question. We're changing the mass to molecule. I think the hardest question will be the last question. This one, the calculation question. So we will practice until you prove on this part. Yeah. So mass converted to molecule. So first we take the mass now, 0.5 gram. Divide by the molar mass is 151. You get the number of mole is this. And because number of mole is the same, you can put in here. Yeah, because the number of mole is the same, 0.00331. Yeah, okay, can. No need to write down nitrogen. Nitrogen. Got it. Put nitrogen here. Different answer. Let me check again. Calculator. 0.5 divided by 1. 331. Yeah, 331. What you get? 0.00331. Yeah. So, you can, you calculated this times 10 power of negative 3, is it? Then your calculator, right? You find this button, you press Shift ENG, then Shift ENG. You get this. Or you want to write the one also can. So if you want to write 3.31 times 10 power negative 3 mole, also okay. Yeah. Now once you get this already, this is molecule. You get the molecular. So here the question here, okay, every day you only can take 2 pill, 2 Panadol maximum 4 times in 24 hours. Okay, the maximum. So now they want you to calculate the maximum number of mole that you can take. So the number of mole of one pill is this number. Okay, then maximum one day I can take 8. So this is the number of mole. Uh, the one is you get from the textbook. Follow the textbook. That's okay. So here is given here. One adult maximum can take 2, 4 times a day. So means you cannot take more than 8 tablet in 24 hours. So now you know one tablet is 500 gram, 500 milligram. So we calculated 500 milligram is about 0.00331 mole. Then take times 8 because you can take 8 tablet. This is calculation with application, means related to daily life. Okay, then now they ask for the mass for 0.1 mole of paracetamol. So you put in 0.1 mole, you get this. It's a very basic calculation. Normally we will put then you know the glucose no, is C6H12O6 ma. So this is how do you arrange the CHO like this? Okay, so this is the one, the first question. We will practice until you're very pro. Okay, now we will practice this question. First, can you try to calculate how many C, how many H, how many O? I think the hardest question will be this part for the paper. The chapter one, you have your seminar notes, right? You have a QR code. So in the QR code, right, if you scan, you're able to get all the answers. And I got put some objective question for you also. So if you want to practice objective, then after that, chapter one, I also put inside that some short notes about chapter one, and then after that, the video also, so that you can go through chapter one, because chapter one is important for your first exam, means the June exam. Okay, so calculate how many C first. 1, 2, 3, 4, 5. This question they actually try to let you calculate wrongly. So now they want one more of that's really the formula. If you calculate wrong, the whole question gone. Let's say you calculated supposed to be 20 carbon, you calculate 19, so this whole question gone. Yeah, so now you use the formula molar mass. So molar mass, this is carbon is 12, this is 1, this is 16, 2 times 20. How do you get C10? Oh no, this one is the typo 20. Okay, then after that, use the formula we mentioned. So this 286 gram per mole is they'll give here, given here, C and H and O. Okay, so this molar mass means how many gram per mole. Then they want to get 0.025 mole. How many? You can see that this question is, you will get full marks if your formula is correct. So remember, this type of question will come up. Please calculate how many C, how many H, and how many O slowly. Okay, then you can put in the 0.025. The mass, molar mass is 286. Six. Okay, after that, now they want to convert molecule to molecule and gram. So it's the same. They actually try to change mass into molecule. So use the mass formula and the molecule formula. So I got 20.2 divided by 286. So you get this, that put inside here. You get 0.07. So number almost the same. Then you calculated your molecule. Okay. Then for the next question, they give you molecule. The buddy wants you to find the mass. So this one is the terbalik process. You have the molecule. They want you to convert to mass. So it's the same calculation. You just switch the position. One side change to the now you started with the molecule. How many molecule you have? Then you divide by the 6.02 to get how many moles. Then here convert to here to change it to mass. This one, when you're keen to calculate it, be careful. You know this, I think you did in school already. Remember to put bracket. So I think this type of question should be no problem already. Okay, now, so you're confident of this type of question, huh? You have quite a number, because if let's say you have essay, right? So your essay will full with calculation also. And later we'll try the chapter 2 question. You have okay. So this is the we will go through all the chapter 3 calculation, then we end with chapter 2. Chapter 2 quite simple one. So I do chapter 2 end of the class. Yeah, so this is chapter 3 question now. So you're okay with the first type of question now. So very simple one. They're going to give you the formula. So you calculate how many C, how many H, how many O. Yeah, then after that, from there, I don't know, you have the answer later also. So we here is don't busy with copy answering, but you understand the method how to calculate. Feel confident. Okay, so this is the first type. Okay, the second type of question normally appear in essay. Okay, we will go through the second type of question. This one is the first type. This one normally in structure. You all feel confident on this question? Yeah, yeah. The answer we'll give after the class, not now. Yeah, you will give after the class. Yeah. So you're okay, yeah? Or you want to try one more this type of question to build the confidence. This type of question about 10 marks bar. Okay, we try one more to see whether you're okay or not. Now, first, let you try. You calculate this. How many C, how many H, how many O, how many N? So the first type of question we done for chapter 3 is the experiment question. You get one experiment question, so there will be a 10 marks. Okay, assuming every question is 10 marks up. Then the second one will be this type of calculation. There will be a third one. Third one will be empirical formula plus this calculation. Okay, you need to calculate how many C, how many H, O have 1, 2, 3. So you calculate. You get answer already? What is your answer? This time, the third question is for you to try it. You have to calculate how many C, how many H, how many O, how many N. This is the third question, so I let you try. You practice. Chapter 2, don't worry, the question very standard one. Chapter 2 question very standard. Ask you proton number, neutron number, all this. Can I calculate that? Yeah. So you try answer. Correct. 8 carbon, 11 hydrogen. Okay, so the second one. Now they request molar mass. So remember, molar mass has unit, or relative molecular mass no unit. Molar mass has unit. Gram per mole. So you calculate for me what is the molar mass. Oh, this one, I forgot to type. Carbon is 12. Hydrogen is 1. Oxygen is 16. Nitrogen is 14. And you'll give an example, don't worry. Okay, calculate for me. What will be the mass? No, you can put CHON also, no problem. Okay, man. As long as the C is the first one, second one is this one, then third one is oxygen. Nitrogen you put at the third one or fourth one, okay, doesn't matter. Calculate. So you got 8 times 12 plus 11 times 1 plus 14 plus 3 times 16. You see how much you get? You need to write, follow this one, CHO, the arrangement. The N you put behind or in front. Normally I ask my student to put all behind. I mean, put the CHO first, the rest behind. Yeah, you get this 169. Okay, now same with the first question again. Just now we did this one. They want to convert mass to molecule again. They want to change mass to molecule again. They got this gram, one converted molecule. So changing mass to molecule. T must be in front. CHO. You remember the glucose? Glucose, the theory C6H12O6. You follow these rules. Follow the glucose formula. Yeah, so now you take the 5.75 then 169. The nitrogen you want to put behind also okay one. Yeah. So you need to arrange according to the C versus H, O, then the N you put last one also okay. Oh, you can take 3 to 4 significant. 2 to 4 significant. This is my option. Vitamin B. Okay, so this one, they want to get the mass up. So standard, this one is a very basic question. Okay, the formula now is CHEM.
C8H11NO3. So the empirical formula, you can't simplify it, so follow back the same answer. Yeah, so that's not okay. Now I'm done the first one. Okay, so this is the second type of question that you'll get for chapter 3. Normally, student lost a lot of marks for chapter 3. Okay, now the third type of question you get will be this. Okay, this type. So this type of question, right? They will started with all this how many percent, how many percent, how many percent, and the rest is oxygen. Okay, so need to put bracket. Need to put bracket. Which one need bracket? I mean this one here. Then you just show D. Got bracket. Oh, I mean the box. The box not even the one I draw for you. And okay. Now so this is the one that they're going to give you percentage. So now this is what we do. We assume we have 100 gram of sample. Why? Because 100 gram equals to 100%. So I can direct change the percentage into gram. And then the last one, how do you get this one? You take 100 minus 74.10 minus 7.4 and minus 8.64. Then start to divide by the mass. This type of question is quite this is the third type of question. The calculation will have two. One is in structure, one is in essay. This one most probably will be in essay. More steps. Yeah, so you divide. Okay. Now then you divide by the smallest number. So this is the smallest. No, this one is the smallest. This question normally in essay, and then it will be quite tricky because the number chapter 2 don't worry, I got the video. Later when you enter the QR code, right, you see in the Google Drive there's a video link. So in the video link, I got teach all the theory, but those video not include this calculation video. The calculation I didn't put in the video for you. Chapter 2, I got teach in detail in the video. You can watch from there. Okay, then you divide. This question will be slightly tougher because the empirical formula is very different from the copper 2 oxide, magnesium oxide. Magnesium oxide, copper 2 oxide, before you calculate, you know it's one to one already. Okay, so from here, you get the ratio to be 10 carbon, 12 hydrogen, and then 1 N and 1 O. Of course, same we will practice this question few times until you pro. Then later the chapter 2, maybe I do 2 question enough. Chapter 2 very theory, but the question very standard. Okay, after you get the empirical formula, they always, for this type of question in essay, they will give you the relative molecular mass, the actual mass. Then you have to find out the real formula, because empirical formula is the simplified formula. So after simplifying, you get this C10 H12NO. Then the actual formula need to times a number. Example, let's say glucose is C6H12O6. If you simplify to empirical formula, this is how it looks like. So let's say if you want to change it to molecular formula, you need to bracket the number. And you know that N equals to 6. So same, I don't know the actual formula. I can do an assumption that is C10H12 and then NO. Then from there, you put equals to 324. Then you put in all your number. So carbon is 12. To calculate your N equals to how much? Quite standard one. So this is the first question you practice. Then we have second question, also practice until you pro. This is the essay calculation. Will be essay calculation because there are many steps here. So one question might up to 3 to 4 marks. This type of question very hard to put inside the structure. You can put inside the structure CHEM, but the structure need to become 12, 13, 14 marks. But this but it won't be logical because the structure normally about maximum 10 marks. You get this in essay. Okay. Now once you get N equals to 2, so the molecular formula will be bracket 2. You get this. I get 1. Which one? Yeah. This one get 10. We got 8.64. Oh, here it is. Divide by 14. The mass of nitrogen is 14 mass. Then I get this. Yeah. You need to find the movers. Don't worry, I got a lot of questions. The same question, I cloned three questions for you to practice. Yeah, because the number, let's say you get 10.001 or 10.0, like this you can round off, not a problem. But let's say your answer is 1.5, you double it round off to 2. 1.5 to 2 is like many different, quite big difference. Let's say that 10.1, you 10.11, you round to 10 is okay. Small number. You cannot do big difference. 1.5 1.333, then you need to times 3 lor. And later I have this type of question for you also. Yeah, so once you get this already, you get the actual formula already, then they start to ask you all this. So they want to convert from mass this time they want to convert to atom. Yeah. This formula we use again. Same, but this time is atom. So same, you put in the number first. So 20 gram. The molar mass is 324. Yeah, I go through the first question with you first. At least you roughly know the idea. Then we'll try the second question. This calculation you should be all right because we did just now. So you take 20 divided by 324. See how much you get. 20 divided by 3. Get a weird number 0.06173. Then put in this number here. Yeah. So okay, once you get this molecule already, okay, this question is new lah, that you need to convert to atom. So by looking at here, how many atom you have? You got 20 carbon plus 24 hydrogen plus 2 nitrogen plus 2 oxygen. So total up you have how much? Here got 28, 48. So you times 48. This one normally is the assay calculation. You can see the steps on is like a lot of steps involved here. In structure can will be a full marks. Why did the number of particles become molecule instead? First you have to calculate the molecule first. Only to calculate atom because from molecule to atom you need to times 48. This is my method lah. You can straight away times 48 also, no problem. So you all okay? So we all practice another question, huh? So now you try this, get similar question, then you try to practice until you're pro. Okay, now 69.8%, 11.6%. Remaining is oxygen. So 100% minus 69.8 minus 11.6 equals to. We practice one more time until you feel confident. We go for the next type of question. So you get 18.6%. Okay, so once you get this CD, the next steps, take the 6.9 divide by 12. You try the question now, you might get very weird number. So you need to learn how to handle those weird number. By looking at my answer is very simple one. But you complete the question by yourself will be a challenge because you get all the weird number. Same because particle means atom, molecule, ion. Yeah, so you get this CD. You open a number, you get this. Then the smallest number is this. So all will divide by the small number. You see how much, what is the ratio you get? Hmm. Then straight away is more, straight away can write atom. Yeah, you get this. Instead of write number molecule, you know the one is atom, so it's write number atom. So you get the ratio is 5, then H is 10. Then calculate the, okay, now they given you the mass of the molecular mass is 172. So now you need to find out the actual formula. Okay, so you write the empirical formula is C5H10O. Then the molecular formula will be bracket N. Then you put this bracket N with equals to 172. So carbon is 12 plus hydrogen is 1, oxygen is 16. You try this. In the second question, you try to do it by yourself so that you can confirm whether you're ready for exam or not. Oh yeah, the 86, this is the mass. They tell you the actual mass is 172. They said 86 means the actual one is double up the number. You see, if you calculate all the C, H, O, 5C, 10H, and 1O, right? The mass is 86 bar. Then you get the other one is 172. Means the actual formula is not 5 carbon, it's 10 carbon, then 20 oxygen and 2 oxygen. 20 hydrogen and 2 oxygen. Okay, then they want you to calculate number of mole. So for this question, you need to able to calculate up the actual number lah. Are you all okay now? The second question? Okay, then you get the number of mole is 0.09. Okay, another question, this one normally appear in the objective that this is the question. They give you X gram of iron combined with 5.04 gram of oxygen. Then give you the formula is Fe2O3. So in this case, we don't know what is our mass of Fe. Then normally this is what we do. X divided by 56. Then 5.04 divided by 16. Yeah, so you take this 5.0 divided by 16. Zero 0.315. Because the ratio is 2 to 3. Okay, so the ratio is 2 to 3. So you can use this one to calculate. You divide by 3 first. Times 2. So 0.315 divided by 3 times 2. You get this is 0.21. This is another question, but this one normally objective. So 56 times 0.21 goes to 1.7. Wait. Oh yeah, the math's correct. Please again. This one normally objective only. So remember, to get this ratio, the ratio of these two is you divide by 3 and times 2. It's like example 2 chocolate and 3 chocolate. So 3 chocolate is 31.5 cents. So you divide by 3 to get 1 chocolate. How much? Times 2 to get the price of 2 chocolate. Okay, so you okay with this? Okay, so this is the question. Okay, for this essay question, they got a upgraded version. Upgraded version means what? I show you the next one. This is the similar question but upgraded. This is another level, another level. This is another level, the question. So for this, right, is hydrocarbon. So hydrocarbon carbon hydro means got C and H no? This is another level. So now they give you the mass is 85.7%. So you can put this 85.7%. Then this is 100 minus 85.7, which equals to 100 minus 85.7. This is another level. Okay, this is another level. So now you divide first. But this question is harder. That's why I only give 2 elements. They cannot give too many. Too many will be like very confusing. You divide first. So you get this. Then both you divide by the smaller one. So the small number you get the ratio is 1 to 2. Yeah. Now for this just now you put CH2 bracket N equals to the relative formula mass, let's say 52, example, this up. For this question is upgraded version. They don't give you the relative molecular mass. You have to sundry find the mass. Okay, so how do you find the mass? This is what they do. They give you this 5.6 gram of this occupied a volume of 4.48. Means I show you 5.6 gram the mass, and then the volume is equals to 4.48 dm3. Okay, this question is the tricky question. So this is what you do. Since you have the volume, because this is number of mole equals to volume over molar volume, this is number of mole equals to mass over molar mass. So you can use the volume, divide by volume to get a number of mole. After that, you can bring the number of mole to here, then you got the mass, then you can find your molar mass. Okay, the idea is that simple. You take volume, molar volume first. These two, you get number of mole. Bring this number of mole over here, plus the mass. You put it here to get your molar mass. And we know molar mass and related molecular mass, they are the same. The number is the same. So now you put in here. So this question is upgraded version. Use Sundry to find out the related molecular mass. Only you can continue. So this is a very popular essay question in school. Remember chapter 2, the teaching, I look at the time we have only left 20 minutes, but so the chapter 2 maybe if you go to my QR code, there's a video link. You can go to the video link. Then after that, that has the video for chapter 2. I do teaching in chapter 2 for, so you just watch the video. I'm not mistaken, only have 2 video. You watch the 2 video enough. About 10 minutes enough for your exam. Okay, so this is the question I need to make sure you're okay, because if you never do this kind of question before, you get 0 1. Which QR code? The seminar notes here. You scan this one. There's a QR code here. Answer and additional material. It has objective there. Then after that, same also it has the video link. You can link to the video. There's a teaching in the chapter 2. Yeah. Then you get the molar mass equals to 28. This one very popular in schools. If you first time, let's say example, you never do this question before, you confirm get 0 1. Confirm get 0 1. Okay, so I will have 2 questions here. So I practice the first question with you. You get used to the question already. Then the next question, you try it by yourself. Okay, now we do those steps now. So you know the molar mass is 28 already. So now you simplify the 28. You put your 28 equals to the empirical formula to find the actual formula. Okay, this question is consider it's very tough. We're going to practice 2 times. So this is the first time, practice the second time. And this one normally appear in the essay if for school exam, your midterm. You can see the steps. It's an essay. You look at the steps that you write. Well, so many steps is an essay. It's an essay. Can appear in structure also, but the structure will be last structure, because last structure is 10 marks. Okay, then you get equals to n equals to 2. So the actual formula will be C2H4. Hey, you okay? Don't this kind of question, if not enough, I got two more for you to practice. So you roughly get the idea. So this is the advanced question that here to here just now. Then this is the advanced question that get one more step at the middle. You have to centrally find out the thing. Okay, you can try the next question, similar question. Oh, this one let me check. This one not similar. We only got one. This one is another level. Hey, everybody done this already? I just like I got one more part need to settle. Okay. So yeah, I guess because left about 15 minutes only, right? So can everybody turn to this page 34? We forgot we got one more part to settle. Hey, you all have learned this in school, right? The calculation part, page 34. We do some revision on this part. So for this type of question, right? They give you the, let's say you need to write the chemical equation. Okay, no question on this. Then they go give you, I got 9.2 gram of ethanol. Okay. Then they will want to find out the volume of carbon dioxide gas. Yeah. So in this case, is the using volume and mass. Yeah. So this is the mass. Then this is the volume. The only difference here is one is for my ethanol, one is for my CO2. Okay, so now you use your mass divided by molar mass. So the mass is 9.2 gram. Divided by molar mass is carbon is 12. So 2 times 12 plus 5 times 1. Then oxygen is 16 plus 1. I think we learned this in school already. Most of the school, I think, arrived here already. Yes. Okay, so by using the calculator, you can get this in 0.2 mole. Okay, so now we use a ratio method. My ethanol is 0.2 mole. Based on the ratio, here should be 0.4 mole. Why? 1 mole produce 2 mole. 1 mole produce 2 mole. Double up the number. So 0.2 will get 0.4. So this is the sentence you do write in the exam. 1 mole of C2H5OH will produce 2 mole of CO2. So therefore, 0.2 mole of the C2H5OH will produce 0.4 mole of CO2. Then you put in your 0.4 mole here times the volume, you get the answer. You have one question, something, but this is very important because every exam, like Form 4 final exam, next year Form 5 exam, you have this calculation. This is the calculation we bring forward to all the chapters. Yeah, so this is the questions. So you remember, you need to convert your 9.2 gram into mole. Then from the mole, you get the ratio. 1 become 2. So 0.4 becomes 0.2 becomes 0.4. Then from 0.4, you convert to the volume that you want. Or the ratio is here, C2H5OH, right, will produce 2 CO2. So 1 mole produce 2 CO2. So I got 0.2, I times 2, I get 0.4. This one refer to the equation. 1 to 2. So 0.2 mole will get 0.4 mole. Double up the number. The calculation is similar. The only difference is because these two are two different things. You cannot just put the 0.2 into here. You define out the relationship between the C2H5OH and the CO2, the ratio, the relationship between these two. And we found the relationship is 1 to 2. So you just times 2. Yeah. So example this time, the third one, they want is oxygen. So we come in the third factor in here. I want to get the oxygen. So now I remove the last one. Now they want oxygen per volume. Okay, so we look at the ratio. The ratio is 1 to 3. So means this is 0.6 mole. Because 1 mole of C2H5OH put a react with 3 mole of O2. So first, you write down the relationship. 1 mole will produce 3 mole of O2. Oxygen, you okay? Ratio is 1 to 3. Then after that, now you got 0.2. Ratio will be 0.6. Good. This is the idea. This one also important. Your exam midterm will have this also. Yeah, for that, you calculate out your answer. Okay, I'll try one question. I think some of your school teacher might take this question into your exam. So roughly have this idea. So you do the last question. This last question might in exam because this last question very similar to SPM 2022. It's one of the question. Don't know why a lot of school teacher they like this question so much until a lot of school teacher will put this in exam. This is a basic question. So you know how to see the ratio. The idea is very simple. A plus B becomes C plus D. So the relationship is A produce B and here to here is C produced by B. Then A react with B. So you got the relationship. Yeah. So, okay, we're going to continue the last question, the quick one. This is a question that very popular in school exam. So the first one is, they're going to give you this chemical. Then he said that it decomposes rapidly into sodium metal and nitrogen dioxide gas. Okay, so you do write equation. So you write up N3 decompose, become sodium metal and nitrogen gas. They will give you this question. Then you write accordingly. This is your this, then sodium metal is Na, then so the nitrogen gas is N2. Then you do balance equation. Okay, to balance the equation, first, you can see here got 3n ma, here got 2n ma. In order to make it both sides same, you cross multiply. What does cross multiply means? The 2 you times 3, the 3 you times 2. So both sides times. Make it both 6. You see, 2 times 3 equals to 6. 3 times 2 also equal to 6. Then here got 2Na ma, you put 2Na here. This one very popular in school exam. Don't know why a lot of teacher first term means like example midterm they always come out airbag one. For the available question, okay? So same now, they given you the information, the normal airbag is this. They want you to find the mass. Okay, this question why they like to come out is because they want to calculate this mass but they give you normal airbag volume. You need to know that who fill up this airbag is my nitrogen gas because they say the nitrogen gas produced will fill up and expand the airbag. So the volume given here is 557.6 dm³ is nitrogen. It's a keyboard question. It's a keyboard question that they don't tell you the volume belongs to who. You have to read the question carefully to know that a nitrogen gas is the one that fill up the airbag. And my airbag is 57.6. Means inside the airbag is all nitrogen gas. It's very popular question for school. Yeah, so you get this today. Okay, now we look at the relationship, very simple one. The relationship between this and this is 3 to 2. So you write out the sentences 3 to 2. They come with this question because this question also quite special. That the ratio you need to calculate out according to the formula. 3 to 2 ma, so you divide by 3 first, then times 2. You'll get 1.6. This is a special question. School normally like to come with this question. First, is considered kibat because they tell the airbag how much is the size. So you have to know it's nitrogen gas. Second one, the ratio also weird. They're 3 to 2. So you have to divide by 3 times 2 to get 1.6. Once you have the 1.6 a day, then you can get your mass. Okay, so far you're okay for this question? You know how to get the ratio, the 2 and 3 ratio. But this one is the balik because I have this balik to find this. So I got 3 back to 2. Yeah, it's the number of mole. This is the number of mole. The number 2 or 3 is the number of mole ratio. If you're not confident, we can complete the below one again one more time until you feel confident. Oh, yeah, and this is, I think, is the SS one. Check. Yeah, this one got one more question here. This one also give you a good question. I want to do this one just in case we came up the weird one. Okay, I got my this and oxygen to produce this and this. So I write down my equation first. C2H6O burn with oxygen become CO2 plus H2. Molar mass is, you follow the formula because this molar mass is for this. So you follow the Na N3. Yeah. So the ratio, this one is 2. Okay. Then here is 6. So put a 3 here. Okay. Yeah, for that, we check the oxygen we have. Here got 2 times 2 is 4. 4 plus 3 is 7. So here got 1. Here I put a 3. Okay, this is how we balance this equation. Okay, for this question, a bit special. They give you this, but they tell you your oxygen is SS. Your oxygen is SS. So means given you this 2.76 gram of this, and the gas, they want you to find how much is reacted gas. Okay, you got this number map. Okay, unreacted oxygen. So you calculate first. Take the mass to get mole. Then look at the ratio between these two. And this one is a special question you need to know lah. That first you get the 2.76, then divide by the mass of carbon, hydrogen, and oxygen. So carbon is 12, hydrogen is 6, oxygen is 16. Then times 2 times 8. Then you get the mole. If you key into calculator, you're able to get 0.06. Then you use the ratio method. 1, 3. See 1 and 3 ma. So 0.06 then times 3. Here to here is times 3. Here to here also times 3. As I say, chapter 3 is the one that students in exam. Chapter 2, if you look at the video, they always ask the same question: proton number, neutron number, minus proton minus neutron, all this number, very simple one. But this one, you can see the question, they have many patternful questions. You need to practice. Yeah, then after that, you get the volume. Now, once you get this volume, it's not your final answer because he has 6 dm cube of oxygen gas. Then you use 4.32 dm cube of oxygen gas. And now they ask you, how much is the unreacted oxygen? The remaining oxygen. So you minus alpha will be 1.68 dm cube. They said chapter 3 question, they can twist around and you cannot just memorize, then that's why you need to practice the question. So far okay, you're okay with this one? So your school question, I think maximum until this level lah. Okay, so if you don't have, you can stay back to ask me question. But if you're done, then you can today the seminar until here lah, because some of you need to rush to the physical class later. Okay, so any question you can ask me. You can stay back to ask me. Okay, so today the lesson until here lah.